Hi, we are from group 15 and today our lab is lab 4, which is frequency modulation. So I'm going to explain the code, and first we define F as sampling frequency, amplitude of carrier, frequency of measured signal, frequency of carrier signal, and we define also modulation index and measured signal. After we define it, then we have in the ninth lines delta F equal to 100, cap F equal to delta F over Fm. These two lines is used to find the modulation index. And from 11th line until 14th, we use it to find the integration of St as the equation that we use. Then we use this one, the 15 line, to get our modulated signal. Then we use the command plot grid hold on to plot our graph. Then we label it x-axis as time and y-axis as amplitude, and the title will be measures and modulated signal. And for the modulated part, first we use the differentiation commands, and the DEM equal to bracket 0 comma DEM is used to equalize the length of the vector of the differentiator result. And the butter command is used as a low pass filter, and the 10 indicate the orders of the filter, and 2 times Fc over Fs is the cutoff frequency of the filter. Then the RFLT equal to filter BARLO is the fit behalf of filter operation in order to get a smoother demodulated waveform, and we plot the graph. For the result part, when amplitude of carrier is 2, the highest amplitude of the modulated signal will be 2. When amplitude of carrier is 3, the amplitude of modulated signal will become 3 as well, and we change it to 4. The modulated signal amplitude will become 4 too. So from here we can conclude that the higher the amplitude of carrier, the higher the amplitude of modulated signal. Then we change the frequency of carrier signal, which is Fc. When Fc is 50, the amplitude is almost 0.3. The amplitude of the modulated signal is almost 0.3, and when we change the Fc equal to 70, the amplitude of the demodulated has increased. Now is 0.4 something. If we change it to 90, When the FC is equal to 90, the amplitude of the modulated signal will become 0.5 something. From the result, we can conclude that when the FC increase, the amplitude of the modulated signal also increases. Now, we are going to change the frequency of the measured signal value. When Fm is equal to 10, the demodulated signal is like this. And when we change it to 20, the amplitude of the modulated signal will be like this. The graph will be like this, and the period will become shorter. And what if we change it to 30? And when we change it to 30, the graph will become more crowded and the period will become shorter. So we can conclude that the higher the Fm, the more crowded the graph is, the shorter the time period. And then, now we are going to change the modulation index when delta F equal to 100. And we run it. The graph of message and modulated signal will be like this one. And when we change it to 300, and we run, the graph will be like this. The modulated signal will become more modulation. What if we change it to 500? When we change the delta F modulation index to 500, the graph will become more modulated. It means that the higher the delta F, the modulation index, higher the modulation of the signal. The signal will become more modulated. I think that's all from us. Thank you very much.